Dear students, today we are going to discuss a new topic, that is electric field in electrostatics. Now, what is electric field? You are aware of the concept charge, which we denote by Q. Let me say this charge is at the point O. This charge has a space around it. इसके इर्द गिर्द अपनी एक space, up to which the force of attraction or repulsion can be felt by another charge. That space is known as the electric field of the charge Q. So then what is electric field? Electric field is the space around a charge up to which the force of interaction can be felt by another charge. That is the electric field. Here in this electric field, what we do is that we suppose here is another charge Q naught. This Q naught is said to be test charge. This test charge, let me suppose it is at the point A at some distance from here, from the point O. These two charges interact. They interact with each other. Depends. You know, this test charge Q naught is a unit positive charge. It can be attracted by this or it can be repelled by this charge. If this charge and this charge are of same polarity, this is positive, this is already positive, if these two charges will repel each other with a certain force. That force, you know, according to Coulomb's law, F is equal to 1 upon 4 pi epsilon naught Q naught upon, let me say R is the distance from here to here, it is R square. This part is the magnitude part of the force. And if we write it as a direction also, then F is equal to 1 upon 4 pi epsilon naught Q naught upon R square. We write here R cap. This R cap is the unit vector which shows the direction of the force. If we divide this force by the test charge on both sides, that means we write here F divided by Q naught is equal to 1 upon 4 pi epsilon naught Q naught upon R square R cap divided by Q naught. This Q naught and this Q naught will go, and we write here it is 1 by 4 pi epsilon naught Q upon R square R cap. This F by Q naught is nothing but E. इसको हम E से डिनोट करते हैं, known as electric field intensity. Electric field intensity. So then what is electric field intensity? Electric field intensity is the ratio. Electric field intensity is equal to F upon Q naught. So it is the ratio of the force between a charge and a test charge to the test charge. to the test charge. That is, this force is the force between Q and Q naught to the test charge, that is Q naught. Its SI unit. SI unit is Newton per Coulomb. Newton for force, for charge, it is Coulomb. Newton per Coulomb is the SI unit of electric field intensity, and it is a vector quantity. It is a vector quantity. Now, electric field intensity due to a point charge. We will go with this topic now. Suppose here is a frame of reference. These are the three axes. At this point O, which is the origin where a charge Q lies. And here we take any point P where a test charge Q naught lies, such that OP is nothing but the position vector R. These two charges, Q and Q naught, interact with each other with a force given by Coulomb's law. Force given by Coulomb's law. F is equal to 1 upon 4 pi epsilon naught Q naught upon R square R cap. So the direction of the force here, it is along this way, this F, because it is a repulsive force. This charge repels this charge. F is equal to 1 upon 4 pi epsilon naught Q naught upon R square R cap. We take for granted these two charges lie in free space. So we are using here epsilon naught, the permittivity of free space. At the same time, we know the electric field intensity, if this is first, electric field intensity is defined as E is equal to F upon Q naught, which we have already discussed. This is second. Using first in second, पहली इक्वेशन और सेकंड इक्वेशन में, यानी फर्स्ट को सेकंड में डाल दो, we get here E is equal to 1 upon 4 pi epsilon naught Q naught upon R square R cap whole divided by Q naught. This Q naught and Q naught will go. We write here E is equal to 1 upon 4 pi epsilon naught Q upon R square R cap. This is electric field intensity. We can change this R cap. That means we can write here E is equal to 1 upon 4 pi epsilon naught Q upon R square. Instead of R cap, I will write R vector divided by R magnitude. Now we can write this equation as E is equal to 1 upon 4 pi epsilon naught Q upon R, and R square becomes R cube R vector. This is electric field intensity due to a point charge. We can write the electric field intensity in terms of coordinates also. before that, now we have here two charges, as you are aware of this, a positive charge and a negative charge. These are the two charges, positive and negative. The concept: positive charge emits electric lines of force always in outward direction. This is an assumption. We assume these lines are always in outward direction. But in case of negative charge, electric lines are towards the charge. हमेशा ये याद रखना चाहिए, positive charge is electric field lines in outward direction. For negative charge, electric lines of force are towards a particular negative charge. This electric field intensity, we can discuss it in terms of position vector also. Now, electric field intensity in terms of position vector. Suppose we take here a frame of reference again. One of the charge Q is here such that OA, suppose it is equal to R1 vector. R1 shows the position vector of the charge. Another charge is Q0 here at the position B. At a position vector, let me say R2. These two charges repel each other along this way. That means this charge Q repels Q0 by a force along this way. We can write here F is equal to 1 upon 4 pi epsilon naught according to Coulomb's law. Q0 upon distance from here to here, AB square into direction is from A to B, AB cap. I will write it like this, AB cap, the unit vector from A to B. Call it 1. Here, I will take this triangle OAB. In triangle OAB, as you are aware of this, the triangle of addition of vectors, that is OA vector plus AB vector is always equal to OB. From the figure, from this equation you can see it. जैसे ये O और B रहेगा, initial and final, A and A merge, it becomes OB. Or I will write as AB vector is equal to OB minus OA. OA को shift किया. OB from the figure, OB is equal to R2 minus R1. It is AB vector. And magnitude of AB, I will write it like this, is equal to R2 minus R1 magnitude. Therefore, from equation 1, we write F is equal to 1 upon 4 pi epsilon naught Q naught divided by AB square. Instead of AB cap, I will write AB vector divided by AB magnitude. This can be written equal to 1 upon 4 pi epsilon naught Q naught divided by AB magnitude square becomes AB square cube into AB vector, or 1 upon 4 pi epsilon naught Q naught. This AB vector, AB magnitude is R2 minus R1, which is magnitude only, whole cube, into AB vector is R2 minus R1. This is what we say the force. The force between the two charges, charge and discharge, in terms of position vector. Okay, this is all for today. So guys, if you like my educational videos, do share and subscribe Physics Masterji channel.